Good morning to Dr. Rahman. So our group project title is Analyze and Visualize COVID-19 in Malaysia. So this is my group members. And this presentation divide into two parts, which is introduction and technical section. For the introduction, it's been 253 days since the first case of COVID-19 was first recorded in Wuhan, China. 121 days since the start of Movement Control Order (MCO) were implemented in Malaysia, and even successful ways for preventing the virus infection. We still have some cases recorded each day. Malaysia has 8 days for 0 cases locally, which we will always be grateful for, but we still need to know a number of cases for each day. With the whole pandemic happening all over the world, it is important issues to have the need to look after the numbers in order to counter the outbreak that happens each day. For the problem statement of this project, the need to build up a system to analyze and visualize the COVID-19 as a step to counter the pandemic is crucial for the nation. With the numbers, the government can future action and planning in advance to control the pandemic by implementing a plan for the target high-risk state, a high-risk person with certain age and various health background. Overview about the system. We're using the programming tool Python. Using open source web application Jupyter Notebook, we aim to visualize and analyze the case, that discharge case, and in current status in ICU with a particular time in Malaysia as a whole, or with the specification of each state with the number of COVID-19 outbreak for each day. Besides, the system also focuses on the latest case update by states and visualize it for each state in specific time. Finally, the system will also seek to compare cases between states in Malaysia. With the following specific tests, the system will target for completeness in each aspect to get the best result of the system. Next is objective of the study. The objective is to visual and analyze the COVID-19 cases in Malaysia as the whole and by every state in Malaysia. Tools and method in this project. The programming language that we had used for developing this expert system is the Python. To perform more productivity and easy collaboration, we had used the Jupyter Notebook as the main platform for using the programming language. While on the other side, the method that we had used in this project is waterfall method. Waterfall method has been used widely in software development, IT, and even construction as a linear project management approach. It involves 5 phases which are requirement, design, implementation, verification, and maintenance. In the first phase of requirement, we had gathered out the requirement of the system, which emphasize elements that we want to implement. This includes the decision of specific tasks in machine learning. In another way, the requirement phase is one of the components in the planning stage of this whole project. Then the next phase is design phase. In this phase, we had broken up the logical design and physical design. The logical design consists of finding possible solutions with theories and brainstorming, while the physical design consists of ideas that are constructed before being made into concrete specification. In this space, we also include searching for some source code and dataset to find examples of the actual code for this machine learning in a few different websites like kaggle.com and github.com. Overall, the design stage has included us to provide support, improvement, and solidity to the intention that we collect in the requirement phase. After that, we continue with the third phase of implementation. In this phase, the programmers had to specify and implement the requirement to produce an actual code for machine learning. The group provides 7 group members for programming work with the specification of every state and generally in Malaysia as a whole. Eventually, the next stage is the verification phase. In this phase, we test the whole machine learning and checking the specific tasks together to make sure everything turns out in a brilliant way and following the requirement that we laid out in the first phase. As we finish the fourth phase of the waterfall method, the project almost comes to an end. Finally, the last phase is the maintenance phase. In this phase, we have to improve machine learning with feedback from the fourth stage and create a new version. The feedback including bugs, misinformation, and error during production. So the next slide is technical section, which is the second part of the presentation. Library. The library used in our project includes pandas, numpy, time delta, irrelevant, matplotlib, seaborn, as well as plotlib express. Pandas datetime is needed to make it easier to plot the data. This project requires update data from the source. Hence, there is need to import irrelevant to open the required online dataset by its URL. Instead of just using matplotlib as the basic visualization in Python, we decided to choose plotlib.express to help our visualization be more interactive. So this is the code for the visualization. This is the color palette used in this project to make the data to be visualized more clearly.
For the dataset, there are 2 datasets are used in this project. As mentioned before, this project aims to show the current trend of COVID-19. Thus, an updated dataset is required. For both datasets, we use the URL of the dataset from an online source to insert the dataset into our machine learning. So this is the coding that we use. And then for the second dataset, the same method to insert the dataset into our project is used. However, few empty values and none can be found in the dataset that may affect the visualization later. To overcome this, we replace the symbol found in the dataset into none, which only can be found under Wilayah Persekutuan Putrajaya column. Then the function dropner helps to drop any none and none value in the dataset. So this is the output of the code shown below. Few rows have been removed from the dataset to avoid empty value to be visualized later. And this is the code that show the latest update from the dataset for total cases that discharge and ICU for a particular time. To make the analysis data easier, the data is reshaped using the time-melt function. This function is used for in formatting the column to identify variable and measure variable. Note that in the time bracket function, the tail value of the dataset is taken. That means the last and current data is taken from the dataset. Hence, fulfilling the goal to visualize the current trend of COVID-19 in Malaysia. In this visualization, PXD3 is used to show the hierarchical data using nested rectangle. Each of the rectangle is defined by table. This label can be clicked to zoom in and out, and when hover, it will show path bar on the left corner of the tree map. And the output shows the current total cases for total discharge and for total death. No label show for ICU current data as no more ICU cases for the current time. And then the visualize each active cases, death and discharge, and ICU. Before visualizing each data, plot the amnesia is defined first to make it easier to call the function later. Inside this function, plotly.express is used again to make an interactive bar chart with a color sequence that shows the increasing amount of data from the beginning until the current time. And then to visualize the data, function plot.dfmilitia is called again with the variable name inserted inside the function, followed by the color palette that have been defined earlier. So this is the coding to callback function for Malaysia dead cases and the output. And this is the coding to callback function for Malaysia discharge cases and the output. And lastly, this is the coding to callback function for Malaysia ICU cases and the output. Visualize trend between cases, discharge, and death is used again to make the analysis easier. This time, the time bracket function takes all data inside the dataset, not only the tail as mentioned before. The measure variables include only cases, discharge, and death. The analysis is then visualized using px.line. That a line plot is shown in the figure below. And this is the output for visual analysis for the comparison of cases, death, and discharge.
This code shows the latest update for each state in Malaysia for a particular time. The data is reshaped by using temp mail function to make the analysis data becomes easier. This function is useful in formatting the column to identifier variable and measure variable. In temps function, the tail value of the dataset is taken, which indicate that the last and current data is taken from the dataset. In order to visualize the current trend of COVID-19 in Malaysia, in visualization, px3 map is used to show hierarchical data by using nested rectangle. Each of rectangle is defined by label that can be clicked to zoom in or out, and when hover, it will show path bar on the left corner of the tree map. This figure is for the visual comparison of cases between states, where it shows the total amount of the cases for each state. For example, it shows the amount of cases in wilayah Persekutuan Kuala Lumpur, where the total of cases is 2447 cases, while in Selangor show 2094 cases, in Negeri Sembilan 1027 cases, and so on. This figure shows the code to visualize the cases in Perlis. Before visualizing the data, plot stack function and plotline function is defined. to make it easier to call the function later. In plot stack functions, px bar is used to represent each data in rectangular mark. In the plotLine function, px lines is used to represent the data in vertex of a polyline marked into this space. Besides that, this code also used for the others 12 state and for the 3 federal territories by changing the variable name for each state. This figure is the example of the output for the visualizations of previous cases from the coding as shown as before. Next is the graph for cases in each state. For this graph, we are using plot figure to compare cases between states in Malaysia. The purpose we are using plot figure is to create figure objects. The whole figure is regarded as the figure object. It is important to use plot figure, specifically when we want to change the size of the figure, and when we want to add several objects to the axis in a single figure. For the fixed size object are plot figure. It is only has 6 figure possible because it cannot be done until figures add subplot. Other than that, this code is used for the 6 state only by tweaking the variable name for each state. That's all from us. Thank you and have a nice day.